Hello. Yeah, in this video, I want to talk about causal analysis using R, G estimation using GEE. Okay. As you know, James Robbins' G estimation is one of the G methods, a class of causal inference techniques, including the G formula and marginal structural models designed for complex longitudinal studies with time-varying confounders. So this is a body of pretty mathematically sophisticated theories. It specifically focuses on structural nested models and uses the conditional independence between treatment and potential outcomes to consistently estimate causal effects under weaker assumptions than standard regression. And in this method, this method was developed to address the challenges in causal inference with time-varying treatments, which we know is a very sticky issue. Okay? G estimation is important in epidemiology and comparative effectiveness research. And this method corrects bias from time-varying confounding and treatment non-compliance, enabling more accurate estimation of causal effects in complex treatment settings. The good news is even for this very complicated method, we can actually implement it using GEE models in R. Okay, so in this video, I want to show you how we can do that. So the part one is I want to show you how to implement G estimation using GEE for like a baseline covariate. It's not time varying covariates yet. That belongs to part two. Okay. So below I will show you R codes that generate synthetic data, how to estimate propensity score, and then how to do a GEE fit for G estimation. And to do that, we have to do grid search. So we're we need to specify a grid for the parameter we're trying to estimate, and then we have to do our own optimization here. Okay, so first let's load in the GEPAC library, set random seed, specify the sample size, the confounder, the treatment, and the outcome, which is related to the treatment and confounder plus the error term. And this is what it looked like. So here the confounder L is a constant. Okay? And this is not a longitudinal data set. Okay, so next step, we calculate the predicted probability of treatment given confounder. So this is also propensity score. So we fit a logistic regression model of the outcome on the confounder, and we add that response estimated probability into the data set. And next step, we need to define estimating function for G estimation parameter with grid search. So we need to write our own G estimation function. So you can see this function X data, and you calculate the difference between Y and data Y minus X. Okay, so whatever you're ready into that X. And then you fit a GEE model here, but you specify independence correlation structure. So basically you're doing a logistic regression, you extract this coefficient, and you return the absolute value of the coefficient. Okay, and then you have to specify a grid with the plausible values of X to find the root. Okay, so here in this case we will search between 0 and 3, and the length out is 100. So we set up the grid, and then we have to evaluate the estimating function using that data set, and then over this grid we just specify. So these are all the values for the estimating function over the grid based on the data set. And then the G estimate is we search over this grid and we find the minimum value for that estimating function. Okay, and so this G estimate causal effect is 1.848485. Okay, all right. So part 2, I want to show you how to do G estimation in the presence of time-varying covariates. So we use the same library, same random seed, but we need a new data set. Okay, we create a sample size, number of repeated measures, and then we first set up an empty data frame with L, A, and Y, and then we do a double loop, like for each subject and for each time point, we specify the baseline, and then if not baseline, we have a formula to calculate, that previous A, previous L, and then we generate treatment A depending on concurrent L and possibly past. Okay, and then we just generate that data set. You can look, it's a very typical longitudinal data set with ID, which is repeated a couple times. You have the time, that's the visit, and you have LAY there. But now here, L is a time varying covariate. Okay. All right, and then we can do the same, we can follow the same steps. So we estimate the propensity score model, and then we just augment that estimated response into the data set, and we specify this estimating function the same way. We specify grid, we evaluate the estimating function over the grid, and then this is the G estimate of causal effect with time varying covariates on the outcome. Now it's 2.060606. So it's a little bit larger than the constant covariate. Okay. But if you ask, oh, we only get a point estimate, can we do some statistical inference such as like confidence interval? If we want that, we have to bootstrap. So here I'm gonna show you some R codes, 200 bootstrap, and then specify an empty bootstrap estimate instead of random seed. And then you do this bootstrapping, just do a for loop. And it's gonna take a while, so let's wait. Okay, well, we'll wait it for, I don't know, about 8 minutes. It finished the bootstrap. Now let's see the confidence interval, lower limit, upper limit. And now we get the 95% bootstrap confidence interval for the G estimate between 1.939394 and 2.151515. So it is a non-zero effect with 95% confidence. All right. Okay, so I hope this video helps for you to learn how to implement the mathematically complicated G estimation using GEE models. Thanks for watching, and please like our video and recommend it to other learners, and please subscribe to our learning channel. Thank you for your support.